Hi class. In today's lesson we're going to look in more detail at the advantages and disadvantages of CAD, specifically more in relation to how CAD impacts on things like CNC and computer-aided manufacturing, and also how CAD renderings are often used in advertisements and for testing and simulation. So, and the background to this is that in the higher course, advantages and limitations of CAD is a general point that's made in the Using Technology and Graphic Communication section. However, that does kind of give a fairly basic sense of what you might be asked about, because there have been quite a lot of different questions asking about why there would be certain advantages to CAD, or maybe how you would use CAD for manufacturing or to support manufacturing or testing. If you have a wee look in the past papers, you'll find examples like this one here, describe given two reasons how a CAD model can be used in production, or how it can be used to support manufacture. And also, if you have a look for advertising, you will find that there are other questions about, asking you about advantages of CAD for advertising, manufacturing, and so on. So it does come up and it comes up regularly, and there are fairly common themes in the sorts of things that you can answer. But because CAD is used in so many different scenarios and industries, the context of the question is important to consider. So it's important that you read the question carefully and think a little bit about what the question is asking you about in terms of, is it a product, is it about a rendering, is it about a building or a structure of some sort. So do think about what you'll learn about these advantages and disadvantages of CAD in that context, and let that kind of direct your answer. Because although there are some kind of common themes that you'll see if you look at the past paper answers. You can't guarantee that just throwing one from memory down will necessarily get you the mark. It has to be relevant to the question that was being asked. So anyway, on our classroom, what I've done is I've got this materials post here, which this video will get tagged onto the bottom of. Unfortunately, it won't go at the top. So what I'm asking you to do is watch this video, and then I've attached a bunch of other videos here, which I think you'll find relevant. I'll maybe come back to talking about them after I've gone through the content, because my intention is not to take too long to go through the slides, and then let you spend a little bit of time watching some of these videos to review, really, I guess, the context of this content. It'll help you understand the real application of these things. So let's just start by having a quick look through what we might be looking at finding advantages in. And the first one would be maybe manufacturing. And so we're going to actually look at manufacturing from a perspective of not just the process of actually making things, but the kind of preparation for that, because a question about production or manufacturing might actually be looking for answers in relation to these points. So the first one, as an advantage, particularly of CAD, is that we can use testing and simulation methods such as FEA, which stands for finite element analysis, and that allows us to model things like loads, material stress and strain. And we could also use CFD, which stands for computational fluid dynamics, which is about the movement of gases, liquids, and also thermodynamics, so basically heat transmission through things. Now, there's a whole, that becoming a CFD or an FEA engineer is an entire discipline of a career in itself. So there's only so much that I could realistically round up in one slide. But basically, if you're ever designing something that's going to be used and has any requirements in terms of withstanding stresses and strains, or has to contain or transmit fluids, or even pass through them, like for example, if you're designing vehicles and you want them to be aerodynamic, you might make use of these kinds of packages. So for example, CFD would simulate how water in a pumping system might flow, or test the effect of different water pressures in that system and see what happens to the flow of liquid through it when you change these variables. FEA could test materials that are specified for a component and see if they would bear the loads that are encountered in use without failing. And so we can see this example kind of at the bottom here of this framework built for a vessel to stand on, or it's for a motor. And the kind of result shows us where there are kind of stronger areas and weaker areas. Usually these results are amplified visually so that it wouldn't actually bend that much. It's kind of done to make it easier to understand. Likewise, you'll see that FEA is now used quite a lot in automotive testing, because for crash testing it's really expensive to keep smashing cars up. So it's better to do as much of that in development work digitally and do simulations that you can then base your design off, so that you don't have to maybe do as much physical testing. And it can be used for all sorts of things, but primarily it's for function and safety. So we'd think about whatever the thing has to do, and whatever the safety issues around it might be. What loads is it going to have to deal with? Those are the kind of starting points for thinking about where we'd use them. And the big advantage is it's much quicker, because we can do this on a computer generally much more quickly than we would if we built a prototype or a structural model. And that means it's then cheaper to optimize our designs earlier in the process, so that we can get closer to the right answer earlier in the process of developing whatever it might be, whether it's a building, a vehicle, a games controller, a pipeline, a water slide, whatever. Now, CAD can support manufacture through testing a whole range of things, but the common things, if you're asked about how it would support manufacture, these are the common things that we would look for in a response. So it could allow us to test moving parts, strength of parts within an assembly, how the parts will actually fit together. So we could assemble them digitally, and we could do a mechanical test where we make things move, check that they don't bash into each other as they're spinning, for example. It could be the weight, mass. For example, this illustration down here is a center of mass simulation, so it tells us where the center of mass of this part is. That might be useful to understand how well something's going to be balanced. Strength of materials as well. So that's one of the big advantages of using CAD from a manufacturing point of view, is the simulation and testing that can be done in advance of actually manufacturing. Another one is the costing. So this again is kind of pre-production. If you develop a CAD model, these are used to automatically, in a lot of cases, provide a BOM, or bill of materials, as it's properly called. Now, that just allows you to generate parts lists. So if you've got an assembly or sets of sub-assemblies, you can detail the quantities of all those assemblies and sub-assemblies, maybe even including things like nuts and bolts, which are standard components you've inserted from a library. So rather than you or your production engineer having to go through all your models and count off all the individual parts and hope they got it right, you can generate a live, up-to-date, accurate list of exactly how many components you need. And from that, you can develop costings, because if you know all the different components you need, again, your production engineers or your accountants or whoever it might be, quantity surveyors if it's a building, they can look through that list and understand the costs, so they can tally up the costs against all the quantities, and that makes it really quick and easy. Well, say really quick and easy, relatively quick and easy compared to the alternatives, for them to get to a point of understanding how much it's going to cost. So it can help you basically work out the costs of a project. You can derive that from a CAD model. And it can, even if you're doing production runs with a CNC system, computer numerical control machinery, machine time is something that's billable. So if you are going to run a component that's going to take an hour to machine, an hour on a machine has an associated cost, because machines have a lifespan, they need to be maintained, they may be on a rental agreement, for example. And so if you can calculate the time cost of producing something and maybe refine that, it allows you to figure out, as well as the materials costs and the component costs for all the other little standard parts that are going to go into it, it'll help you to understand how much it's going to cost you as a whole to maybe make something. We then also are wanting to have a think about the actual process, or production of things. So there are some obvious examples of how CAD can support that. One is that we can use our 3D models to directly manufacture things. So essentially we can use our CNC or CAM systems to generate toolpaths for our CNC machinery. So you'll see in one of the videos attached, or a couple of videos attached, a little bit of an illustration of that. But for the machinery that's going to produce our part, we can digitally just extract that from our model, rather than having to have somebody manually do it, or having to manually program a machine. The dimensions required for manual or CNC manufacturing can be identified or communicated by extraction from a CAD model as well. So we could, for example, just open a CAD model up and analyze different features of it without necessarily even having to make a drawing if we wanted to. But equally, we could export a production drawing directly from a CAD model if we do need to pass on drawings. 3D models can also be used to show how complex items, like this assembly over on the right hand side here, are assembled on a production line maybe, or just from a training point of view or for maintenance. And that can be really useful. You'll also see an illustration down here of a CAD assembly line simulation that's quite often done to kind of figure out how things are going to work in an assembly line where you've got a lot of complex components being put together and a lot of different people, different tools, different workstations. So, those can all be quite useful. And as well as that, it may be that it's just simpler for a manufacturer to interpret information from a CAD model than it would be from a production drawing. Because looking at production drawing might take a while to kind of get your head around, particularly with a complex object, whereas with a CAD model, you can just open it, you can look at it in 3D, you can explore it, take it apart, and so on. So there are a range of big advantages for the actual process and production side of CAD as well. Now, the final one I'll talk about is not really about production, certainly, but it is an advantage, and it's very frequently asked about, i.e. why would you use a CAD rendering, or why would you make a rendering? What are the advantages of that? And we all know ourselves that we can create good quality renderings from our CAD models, not necessarily always in our CAD software. Sometimes we need to take it to another piece of software to improve it and make it really photorealistic, get all the lighting and everything just spot on. But the main advantages we'd be looking at there are things like giving a realistic representation of what the final product, or maybe building, depending on the question context, would look like before manufacturing or constructing it. We can use 3D models to make photorealistic renders, and those can be used to show, for example, different materials, colors, textures, options to distributors, consumers, and other non-specialists. It may be in the case of a building that you would use your model for planning consent to create these renderings, because your planning officers might want to see the appearance of the building and check it's in keeping with other surrounding buildings. So being able to see materials and all that sort of stuff is really useful there. But as I say, non-specialists, from an advertising and promotion point of view, we want to be able to show a product potentially to people who are either end consumers or maybe other people who are involved in the supply chain of that product and are thinking about being involved in the project. Now, the other things that we could do, for example, are create model animations. So from a point of view of creating an advertisement, it might be that it's actually simpler to create what you want to have in your television advert from a really well rendered model than it is to actually try and make it happen with the real thing, because you can then use CGI and animation to create your visualization. And we can also place them into scenes and contexts to enhance realism. And again, that might be easier to do with a model than it is with a real thing, depending what that context would be. And very obviously, big advantages of CAD models to advertisements and promotions is that we can use them to make these renderings for promotional materials, such as print or digital things like posters or websites. It could even be that we'd have on an APRA website a three-dimensional model that could be rotated around, or at least visually would appear to be rotated around. It might just be a sequence of images. So that's kind of our list of the key advantages. I've gone through them quite quickly. You can take more time to read through this yourself, and I would make some notes from them. So just get a wee kind of notepad and note out the key points. How would you distill them down to like a simple point? And I would also suggest that you do have a look at the past paper questions that you'll find, look at the marking instructions. Hopefully you'll see the relationship between what I've just talked about and what's in those marking instructions. Now, to supplement the very, well, I'll say quite brief lesson I've just given you, because I didn't want to go into a lot of detail, I have added in a couple of different videos here that I'd like you to have a look at. These first three here are really about CNC, or the kind of CAD-CAM relationship, because it's quite a common thing to be asked about. And it's one of those things that I think is difficult to explain just verbally, or even with a slideshow. Sometimes you kind of just need to see how it works, see that relationship, see what the machines do, and how it is that the CAD model relates to that workflow process. And this last one here is actually kind of this third one here is kind of a more of a hobbyist approach to using CNC. But the problem is a lot of the videos on use of CNC in industry are really quite complex and maybe a bit more complicated than you need to understand it higher. So in terms of understanding this workflow between modeling something in CAD, using CAM to create your instructions for your CNC equipment, and then actually using that code that's generated by CAM in a CNC machine to manufacture something. It kind of goes through that process quite nicely and in a fairly short format. There's also a link to a video about SimScale, which is an online platform. It's actually a good example of cloud computing as well, whereby you can do basically simulations. You can use it for free. I kind of logged into it here. It does take a really long time to calculate things, though. You can see this simulation for flow through this pipe has been calculating for 93 minutes, and it's still not done, and that's quite a simple one. But the service itself can do all sorts of really clever stuff. From FEA, which is your stresses and loads, and figuring out whether things are going to be strong enough, basically, right through to really complex fluid dynamics. So this gives you a wee introduction. Some of the terminology will be a bit more complex than you need, so just kind of watch it with a view to taking a general impression of what you would use FEA and CFD for. What can you do with that? And I've added this wee outline here of what bill of materials is. Again, you kind of just need to understand that you can use CAD to generate costs through extracting a bill of materials. But I always feel it's better to kind of understand things a little bit more in depth. So this video here will hopefully kind of expand on that for you. I don't want to make this any longer than it needs to be, because I did say I intended for you to have a bit of time to watch through these before your next lesson. Do make sure that you do engage in this as much as you can, because there will be questions on this in your next quiz, and almost certainly will be questions in your exams that you have coming up. So the more time you put into understanding this now, the better. Okay, let me know if you've got any questions, and I will see you in our next lesson. I just realised as I was finishing the last video that I hadn't actually touched on disadvantages, and I will do so, but only very quickly. There really haven't been any questions that have come up about this in the past papers recently, but if there were to be any questions, I would consider the following issues in relation to the question context. First of all, cost. CAD, FEA, CFD software, CNC machinery, skilled operators, all that sort of stuff is expensive. And that will not always suit some businesses. For some businesses, unless they're working at a large scale with very high value contracts, it may actually still be more cost efficient just to stick with simpler, more traditional methods. Time, again, while they will save time with a workforce that's trained to use them, and in a situation which they are well suited to, the initial investment in time to change company processes and train your employees might be a barrier, and it might not be worth it for some. Complexity, again, with any technology, particularly with software, comes the potential for technical problems that might be more difficult for you to resolve than would have been encountered with previous ways of working. For example, there are very few things that can go wrong with a technical drawing board, but if you're doing something in CAD and it goes completely wrong, unless you're an expert or capable, it might be more difficult to deal with it. Likewise with machining things manually versus using a CNC system. And finally, there's a physical tactile thing. So in some scenarios like architecture and product design, modeling is still really important, because having a tangible model that you can see and touch might provide an impression you just won't really get from a computer model. Now, that's been negated a bit more by technologies like 3D printing, because that allows you to basically create these 3D physical models really quickly from CAD, and can actually enhance it. And there are also technologies like these 3D visualization systems where you can put on a mask and kind of in virtual reality handle things and move them about. But again, there may still be a kind of a tangible difference between what you can produce from CAD and what would be a kind of handmade model. So that again might be preferable to some people in some industries.